What's up, y'all? It's Mr. Canada, and welcome to my math domain. In this video, we're going to be talking about the standard form of the line, one of the three forms of a linear function. We're going to be talking about how the standard form looks like and how we can use the standard form to find the x and the y-intercepts from the linear function, and also talk about how we can convert standard form into slope-intercept form. So let's go ahead and get started. Like I mentioned before, the standard form of the line is one of the three ways that we could write a linear function or a linear equation. More specifically, the standard form of the line looks like this. Ax plus by is equal to c. One thing that you need to keep in mind about the standard form is that a, b, and c are just integers. So a, b, and c are just regular old integers, which, by the way, that means that they could be whole numbers that could either be positive or negative. So usually in standard form problems, there's going to be numbers located in these spots. Now, to be a little bit more specific here, the letter A in particular is always going to be a positive integer. And that's just sort of based on the definition on how we write the standard form of a line. So just keep that in mind. The standard form usually has two variables on one side of the equation and usually a whole number chilling on the other side of the problem. Now, we can use the standard form of the line to find the x and the y-intercepts of the linear function. And how we find those points is actually relatively pretty simple. Check this out. Let's say that they gave us a problem like this. 4x plus 3y is equal to 12. This is an example of an equation that it is in standard form because we have x and y on one side of the equation. So what do we have to do in order to find the x and the y-intercept from a standard form linear equation? Well, let's kind of recall these two facts. The first fact to recall is that the x-intercept is the spot on the table or on your graph where y is equal to 0. And on the flip side, the y-intercept is the spot on the table or graph where x is equal to 0. Let me kind of fix this. There we go. So how exactly do we use these two pieces of information to actually find the x and the y-intercept? Well, really it comes down to this kind of idea where all we're really going to try to do is plug in the 0 into the appropriate spot in your equation and then simplifying whatever is left over. Let me kind of show you what I mean by that. So let's say that we wanted to start looking for the x-intercept for this particular equation. Well, let's go ahead and start by writing this equation down one more time. 4x plus 3y is equal to 12. Now, if we wanted to find the x-intercept, what we're going to do is we're going to plug in, we're going to substitute the y variable in the equation with the number 0. So it'll look something like this. 4x plus 3, and we're plugging in that 0. So parentheses 0 is equal to 12. Now, one thing that we should be aware that what happens is that if we wanted to continue to simplify this, we would multiply 3 times 0. Now, remember that anytime you multiply anything with 0, it's going to get you to 0. So one really cool thing that'll happen after we plug in the 0 here is that this is going to disappear from our problem. So all that's left over after we plug in 0 is going to be 4x is equal to 12. And then from here, we just sort of solve the equation by dividing both sides by 4. So our answer is going to be x equals 3. Now, why exactly did we do all of this work just to get an answer of x equals 3? What exactly does that mean to us? Well, this x equals 3 is basically the x-intercept of this linear equation, which means that what we can do is say that this is the point 3, 0. That is what we're shooting for with a lot of this work. And all we did was we substituted y with 0 and sort of simplified and solved the equation afterwards. And we should be expecting an x at the very end because we are looking for the x-intercept. Now, if we wanted to find the y-intercept instead, the work is very similar. But there is one small key difference. Instead of trying to plug in a 0 where y was, this time we're going to be plugging in a 0 where x is. So in this case, what does it look like? Well, 4 times 0 plus 3y is equal to 12. And again, just like before, this 4 times 0 is going to simplify out, and all we're left with is going to be positive 3y is equal to 12. And again, we kind of finish off the problem by dividing both sides by 3. So that means y is equal to 4. 12 divided by 3 will get us 4. Again, because we are looking for the y-intercept, we should be expecting a y at the very end of our problem. Y equals 4. Now, because it is the y-intercept, we got to make sure that we write our answer in the appropriate way, using the correct notation. So that means that as a coordinate point, this would be 0, 4. So keep in mind what we're trying to do here. We're trying to just plug in the correct 0, or the 0 in the correct spot. If you want to look for the x-intercept, you just got to make sure you plug in 0 in for y. If you want to look for the y-intercept, you got to make sure you plug in 0 for the x. And this is true no matter what type of linear equation you're working with, whether it's in standard form or whether it's not. But it's super convenient to work with it in standard form. Let's do one more example just to go ahead and bring it home. So let's look for the x-intercept first of this equation here. 2x minus 4y is equal to 8. Okay, let's look for the x-intercept first. Well, if I want to look for the x-intercept, I have to make sure that I plug in a 0 wherever I see a y in my equation. So that means that this is going to be 2x minus 4y is equal to 8. I'm going to plug in a 0 in place of the y. And I'm going to start simplifying. 4 times 0 is 0. So that means it's just 2x is equal to 8. And then we divide both sides by 2. X is equal to 4. But as a coordinate point, we should recall that this is your x-intercept. So that means we should be writing our answer as 4, 0. And now we would repeat the steps with one key difference. This time, we want to look for the y-intercept. So this time, we have to make sure that we plug in a 0 for the x this time. So 2x minus 4y is equal to 8. Let's go ahead and plug in a 0 here for x this time because we are looking for the y-intercept. Like before, 2 times 0 will just give you a 0. So more or less, all that's left over will be negative 4y. I can't tell you enough how important it is that you bring down that minus sign because it'll make a very, very huge difference because what we're working here at the end of the day is a negative number. And if we ignore that negative sign, we're pretty much changing the problem itself. And then we just divide both sides by negative 4. And we're left with y is equal to negative 2. But again, let's write it in the appropriate way. 0, negative 2. That one went by a little bit quicker, but the work is the same. Make sure that you are plugging in the 0 in the right spot whenever you are looking for the intercepts. If you're looking for x, plug in a 0 for y, and vice versa. If you're looking for the y-intercept, make sure that you plug in x equals 0 in for the x. Now that's not the only thing we can also do with standard form. In this case, this is one of the good advantages of using standard form. It's very simple and straightforward to find your intercepts. But the standard form also has its own disadvantages. One of those disadvantages is that the standard form doesn't necessarily tell you right away what the slope of the line that you're working with. Now, in our previous discussions, we've talked about slope-intercept form, y equals mx plus b. And the reason why it's such a powerful version of a form of the line is because it directly tells us right off the bat what the slope is and what the y-intercept is, which when it comes to lines, those are the two most defining features. But standard form doesn't tell us the entire story. So one thing that we can do with standard form is that we can convert it into slope-intercept form by isolating the y variable. So let's kind of think about what we're going to try to be doing here. So let's try to see what kind of steps we have to take if you want to convert the standard form into slope-intercept form. So here's an example. Here we have 4x plus 3y equals 12. Well, what do you know? That's a very familiar example. It's the one we just did. But this time, instead of finding the intercepts, we are going to isolate y. We are going to solve for y. And again, why are we solving for y? Well, in slope-intercept form, the equation is y is equal to mx plus b. The y variable is completely by itself. So if we wanted to change this into something like this, we have to isolate y, solve for y, keep y by itself. So what kind of steps do we have to take in order to do that? Well, step one, in order to start converting this, is that you want to move the x by using an inverse operation. So to do that, what we're going to be doing is subtracting 4x on both sides. One thing to keep in mind that when you are subtracting x on both sides, make sure to not actually simplify this part right here. You can't simplify 12 minus 4x because they're not like terms. So one thing to keep in mind is to just leave it alone. Just write down whatever you have left over. So in this case, what we have left over is 3y is equal to 12 minus 4x. Okay, now notice that we're pretty much close to where we want to be. We moved the x already. The only thing that's together with y at this point is the number 3. Now recall that anytime you have two things that are right next to each other, it implies multiplication. So again, think about what kind of inverse operation you would have to do in order to solve the problem. In this case, we would have to divide everything by 3 to undo the multiplication of 3. By doing so, this simplifies out. We have y is equal to 12 divided by 3. It's going to be 4. Now we're going to go ahead and divide negative 4 by 3 and see what we get. So I'm using the Desmos calculator, which I think is a pretty nifty calculator. So negative 4 divided by 3. Oh, that's ugly. I don't like that. Here's a suggestion. Whenever we're dealing with anything related to slope-intercept form, I think it's a better idea to keep it as a fraction. So you might notice that the fraction that we divided, simplified, is the same fraction that we have right now. So that just means we're going to keep it the way it is. Minus 4 over 3x. Now here's the thing. This doesn't necessarily look 100% like y equals mx plus b. Because normally we would expect the mx portion of our equation to be out in front. So one thing you could do if you want is kind of switch the order of these numbers here. We could go ahead and put the negative 4 over 3x first. And then because since this is a positive 4, we make sure that we add 4. But just to give you an FYI, even if the order is, let's say it's out of order, it's different, it's still going to be slope-intercept form because at the end of the day, y is completely by itself. So let's kind of recall what these steps were. Step 1, more or less, is that we want to move x. And then step 2 is that we want to end up dividing whatever is left over in front of y. These are the two steps we always have to perform whenever we're planning on converting standard form into slope-intercept form. So let's go ahead and do it one more time. This time we have the exact same problem we had before. 2x minus 4y is equal to 8. Let's go ahead and recall those two steps. Step 1, we're going to go ahead and move x. So this time again, we're going to go ahead and subtract 2x from both sides. That crosses out. Remember, do not subtract 8 minus 2 and say that it's 6. They're not like terms. Just leave them alone. One thing that you have to be very careful about is that when you bring down this 4y, that you also bring down the minus sign with it. It's negative 4y. On the other side, we have 8 minus 2x. Now we're only one step away, because now all we have to do is make sure that we divide everything by negative 4. So we're going to divide this by negative 4 and divide this by negative 4. So what happens? Well, this crosses out. We're left with y is equal to. 8 divided by negative 4 is negative 2. And here we have negative 2 divided by negative 4. Let's see what Desmos has to say about that. So let me clear this. Negative 2 divided by negative 4 is 0.5. But I would really recommend that you keep it as a fraction. So let's go ahead and click the convert to fraction button. It's going to be 1/2. So this is going to be positive 1/2 x. And again, you can either keep the answer the way it is, as long as you can safely identify the mx and the b portion, or if you want to switch the order, you would have positive 1/2 x up front, and then the minus 2 chilling in the back. But either way, it's basically the same thing. Just remember that the slope is always located right next to the x. They're best friends, basically. So let's sort of recap what we talked about in this video. So the standard form is ax plus by equals c. It's one of the 3 possible ways you could write a linear equation. What's useful about standard form is that we can use it to find the x and the y-intercepts. You just have to make sure that you plug in the 0 into the appropriate spot to solve your equation. And then finally, you can convert the standard form into slope-intercept form by following 2 steps. Moving the x by using the inverse operation, and then dividing everything that's left over by whatever number is in front of y. And don't forget to bring down any negative signs along the way, because it will be affecting your work as you are simplifying. Well, I hope you guys learned something new today. If you have any questions, you can leave a comment below and I'll get to you as soon as I can. If you liked the video, give the video a like and subscribe to my channel for more Algebra 1 videos. And as always, please take care and I'll see you guys next time.